Okay, Assalamualaikum and good day everyone. How are you guys doing? So I hope that everyone is doing very well and can absorb or start to adapt with this new norm of learning, okay, online learning. So now, as I mentioned last week, this week we're going to learn the second chapter of this calculus course, which is chapter 2, differentiation. Alright, so as you can see now, alright, on your screen, these are the sub-chapters of chapter 2 that we're going to learn. So we start with 2.0 introduction. So we're going to see what are the learning outcomes that you are going to learn, that you are going to achieve at the end of this chapter 2. And then followed by 2.1, introduction to first principle. 2.2, techniques of differentiation. So under techniques of differentiation, we have product rule, quotient rule, chain rule, implicit differentiation, and parametric differentiation. And then we're going to see differentiation of trigonometry function, followed by hyperbolic function and also logarithmic function. And all these we're going to learn on how to differentiate this type of functions, quite specific functions. And then before we go into the applications of differentiation, rates of change in circuit analysis, we're going to have a look into the L'Hopital's rule. Okay, this is when you are going to apply the limit theory, limit calculations in order to solve the differentiation question. Okay. So now we go to the introduction. As for the learning outcomes, okay, it is expected that when you're completing this topic, you are able to first determine and compute the derivatives or differentiation by using the correct techniques. Okay. Second, you can able to determine the derivative for specific functions, which are trigonometric, hyperbolic, and logarithmic. And finally, to apply and use the correct methods to calculate the rate of change of the variable in circuit analysis problem. Okay. So now let us move to our first content of this topic, which is introduction to first principle. I bet that many of you already heard about first principle rule, okay, or first principle formula, but maybe to some, no, I think all of you might come across with this one, even the polytechnic students, okay, because I noticed the first principle is available in your syllabus when you're taking engineering mathematics 2. Okay, so this is just actually a quick recap, okay, if I may, quick recap, yeah, to say that just a quick recap. Okay, now we start with okay, a derivative. Okay, so the process of finding, okay, sorry, let me change this one. So the process of finding the derivatives of the function, we call it as differentiation. And by implementing the concept of limits that you've learned previously last week, the last 3 weeks ago, okay, the derivative of fx is given by this formula. Okay, this is the first principle formula. F prime x, okay, equals to limit h approaching 0 for fx plus h minus fx over h. Okay, provided that the limit is exist. Okay, so when we say that the limit is exist, it means that we know that from the left side and the right side, the limit for that function is defined and exist. Okay, now where does this formula come from? Okay, now in order to understand this, we need to look into a graph which is in figure 2.1. Okay, we're going to look it in a short while. So just to note that in that figure we do have point B, point 1, which is point B, and we also have Q, okay, which is to be the point 2. So in that graph we will have 2 points, point 1 and point 2. Okay, and so based on that graph we could find the gradient. Okay, gradient, or we call it as slope. So slope, gradient, or in Malay we call it keturunan. Okay, the slope of the graph or the slope of the line between the P and Q is given by this formula. So let us look into figure 2.1 together, shall we? Okay, this is the figure. Now if you look closely, I mentioned just now we have 2 points, okay, which is point 1, the P, and point 2, the Q. Alright, so there is a graph here. So the graph is this one. Not very clear. Okay, this is the graph. Okay, and from these 2 points between P and Q, we can actually find the gradient of this particular line or graph or curve. Okay, so the formula just now that we can define it. So we want to look, if I can go back to this. Okay, if you look closely, this formula, we have M PQ equals to y2 minus y1, okay, over x2 minus x1. Okay, so let me write it down so that it much be easier for you to relate it. Okay, so initially we have PQ, which is y2 minus y1 over x2 minus x1. Okay, now we define each of these point y1, y2, x2, and x1. So according to this graph, okay, we assume that at point P is actually x fx, the coordinate for P. Okay, the coordinate for P is x and fx. So x and fx is, if you go down here, trace it, okay, it is x, and for the y coordinate it is fx. Okay, now if we go to Q, if you trace down, okay, the Q coordinate on x is x plus h. So we assume that between x to between the first x1 to x2, right? So there is a distance of h, so we can call it as x plus h. Alright, so does this one, we assume it as f x plus h. Okay, so that is the reason why we can write it down using this the new label. Okay, alright, maybe I can reiterate it in here. So y1 we assume as fx, y2 is x plus h. So this is our y1, this is our y2, and then x is our maybe I can change the color. So x is our x1, okay, and x plus h is our x2. Right? So when we plug in the value, okay, so when we plug in the value, right now I want to change to red color. Okay, okay, MPQ using the new defined value. So y2 is okay, y2 is over here, which is fx plus h, minus y1. So y1 is here, which is fx over, so x2 minus x1. So x2, alright, x2 is x plus h, x1 is h. So when x2 minus x1, okay, if you solve this, what you will get is, okay, is what? Sorry, x1 is x, yeah? x1 is x, x2 is x plus h. So when you subtract x1 from x2, you will get x plus h minus x. So your final answer is h. X plus h minus x. Okay, I hope that will not make you confused. So this is over h. So this is similar to, okay, from the first equation that we originally defined like this. So now we can get the newest equation, which is equation 2.2. Okay, this is the same, yeah, same equation. All right, so if you read this, okay, note that when Q approaches P along the curve Y, okay, equals to F, so the x2 will approach x1. So as a result, the h will become x2 minus x1, which then will tend to be 0. So therefore, when Q is close enough to P, the straight line joining P and Q will become the tangent to the curve at P. Okay, so you imagine, you just imagine this point, the Q point. Okay, not very nice, not very obvious color, because the curve is already colorful. So maybe we can pick purple. Yep, purple color. Okay, now alright, we go back to this. So when we imagine, okay, the Q point here approaching to P, moves closer to P, right? From Q moves to P, what will happen is that as x plus h, original condition, going to x, okay, so x2 minus x1, it will tend to become 0. Okay, so when that thing happen, okay, the gradient is no longer exist, and what happen is that it will become a tangent. So a tangent line is over here. Okay, so when Q approaching to P, okay, the straight line, okay, again, if you recall back, when you measure the gradient, okay, the gradient between the P and the Q, you are actually measuring a straight line here. So what is the gradient for that curve? Okay, that is why we compute the MPQ. And then the theory for the first principle said, as the Q moves approaching to P, then the h will become 0, okay, approaching 0. And what happened is that the next straight line will no longer be a straight line because you are moving the Q approaching to P, and what happened is that it will become a tangent, okay, to that curve at point P. So P is over here, so it will become a tangent. Right, so if you look here, okay, this is the redrawn graph. So initially we have point Q here, okay, and then you are measuring the slope over there, okay, so slope for the straight line between P and Q, and then as you move the point Q approaching to P, the new line will become the tangent to that function f at point P. Okay, I don't know whether you understand what I'm talking about, but basically that is how the definition of or that is how you can understand the theory of the first principle. Okay, now, okay, if I may continue. So next is, okay, since the gradient of the straight line is this one, this is MPQ, the gradient of the tangent at P, okay, so we can get through this third equation. Okay, so basically it is similar to the original this is the original one, the second equation one. Okay, the second equation that we defined just now, okay, minus fx1 over h, okay, and then when we want to compute the gradient of the tangent, now we are talking about the tangent here, the tangent point here, so the gradient will become m limit h approaching 0, because it moves from, okay, theoretically there is a distance of h from P to Q or Q to P. So as h approaching to 0, because Q is moving to P, okay, then this one will become, okay, over h. Okay, I don't want to make you confused. we do not need to put x1 over here actually. Okay, because initially in the previous page, let me check, there's no x1 if I'm not mistaken. Yeah, oh, there is an x1, so my mistake, I did not write it properly for you. Okay, so yeah, so maybe I hope that you can excuse me for my mistake here. Pardon me for my mistake. I forgot to put x1 over there. Okay, so basically there's x1, but at the graph there's no x1, so this is actually x1, so to make it correct, yeah, so this is actually x1, this is x1, right? So basically x2 is x1 plus h, okay, so that okay, so the x1 is x1, so okay, yeah, it's the same thing actually. I'm overthinking about it. Okay, so yep, and alright, so back to this. So at the end, we are actually finding the gradient of the tangent by using the third equation here that we just obtained here. Okay, this one. Okay, and So the conclusion is, okay, we can see that the derivative of a function at a particular point is the slope of the line tangent to that function at that particular point. Okay, what is this? Okay, if you don't understand it, that's all right, that's fine. You just need to understand that this is how the first principle is produced or published. Okay, this is actually the gradient of the tangent, and the gradient of the tangent is actually the derivative, okay, the derivative of that particular point. Okay, so let's see example 2.1. So by using differentiation from the first principle, you need to find the derivatives of the following function. Okay, we are going to try example, yeah, maybe we can look at both example. So the first one, okay, this is the step-by-step solution, so I guess it may help you to get better understanding on this. So the question is given that y equals to 2x squared. Okay, then first step is, right, what is the first step? Write the expression. Okay, step 2, obtain the expression difference between this and this. Step 3, simplify the expression, and final step, you will find the limits. Okay, how to do that? We actually want to use the third equation, the first principle equation. So the first principle equation says the gradient, okay, just now, yeah, is the limit h approaching 0. Okay, this is over h for fx plus h minus fx. So basically step 1 is actually defining the step 1 is looking for this one. We are defining this one, and then step 2, okay, we are finding the difference. You need to as you can see, we will find the difference between fx plus h minus fx. Okay, this one. Okay, and then simplify the expression. In this case, we divided it by h. Yeah, if you can see, we are dividing following the formula here. And finally, we put or plug in the limit h approaching 0 into our final expression, so that we can get the final answer. Alright, so m here is actually a derivative, so we can say we are looking for f. Here our question is y, so we are looking for yeah, it's okay, y or fx equals to 2x squared. That is our original question. So in the first step, we want to find fx plus h. Okay, so what you need to do is that you just substitute the x, the variable x here in the original question, with x plus h power of 2. So you know from here what to do. You need to expand this. Once you expand it, okay, x squared plus 2h plus h squared. Okay, and then you expand it again by times up with 2, constant 2. So this is what we get, 2x squared plus 4. Sorry, I'm missing xh here, 2. Let me delete it. Okay. Plus, okay, this is 2xh, so this will become 4xh plus 2h squared. Next is the step 2. So step 2, we already obtained fx plus h. So we are looking for fx plus h minus fx. Okay, so we just copy the previous answer. Plus 2h squared minus 2x squared. Yeah, because fx is here. Okay, this one I already defined it here. And then we can simplify it. Only left is 4xh plus 2h squared. That's the step 2. Now we go to step 3. Okay, this is step 1. This is step 2. And this is step 3. Okay, step 3. Okay, we're going to divide the previous expression that we obtained here by h. We divide it by h. So you need to write down the full formula. Okay, equals to 4xh plus 2h squared over h. You know that you can cancel out. What's left is 4x plus 2h. That is our third step. Now we're going to find the final step, which is to find the limit. And to find the limit, you need to plug in this formula, first principle formula, 4x plus 2h. Plug in the limit here, you obtain 0. Sorry, it's not x. My mistake, my bad. Sorry about this. This is h, yeah. So don't make a silly mistake like what I did just now. H approaching 0, so it should be substitute over there. So your final answer will be 4x. Ta-da! So this is your final answer, 4x. I know, yeah, first principle is very long, okay, but you somehow still need to learn about it, okay. And yeah, actually, if you already familiar with differentiation, if you want to find the y prime for this question, okay, this is the original question, you know that if you want to find it, just as simple as times up this. 2 times 2 is 4x, and then only 4x. This power is need to minus 1. As simple as that. I know. But however, for first principle, this is the longest. There's no other short method or shortcut way method. No shortcut. Okay, so you just need to bear with this. Okay, now let's see another example. Given y equals to 1 over x, okay, then fx plus h equals to 1 over x plus h. And then again, what you need to do is that you need to plug in not to change. Okay, that one. Okay, better. So again, since we need to add fx plus h, that's why in this original one here, okay, I don't like this one. Okay, sorry guys. Okay, so that's why we add plus h in this original function. So basically, if you can get the main idea, alright. If the question, for example, 2x squared plus x, okay, so when you change it to fx, 2x squared plus x, and then okay, and then when you put fx plus h, so basically every x term you need to add with h, okay. this, okay, before you can proceed to the next step. Right, so I think, okay, let's proceed with step 2. So step 2, you need to find the difference. Okay, find the difference between fx minus h, fx plus h minus fx. Okay, this is the step. I'm not going to explain this further. Just show to you guys. It's better for you to do it at home. Okay, based on this video, try to do it at home. And then we go to the third step. Okay, so in third step, you need to divide by h. So basically it's a very pretty simple actually, if you are following the steps or understand the steps, and then you just divide it by h. You notice that you can cancel out the h term here, and finally using this expression we find the limit h approaching 0, not x, yeah, h approaching 0, and this is your final answer. Okay, try to do exercise 2.1, okay, at home, and the answer for this is okay, the answer for this is 1/3 x power of 2/3, right? 2/3, and then the second one is 1/2x minus 1. Okay, yeah, okay, yeah, try to do this one at home. So now let's proceed with techniques of differentiation. Try to finish up all the techniques of differentiation in our first meeting here, first lecture for this week.